טובים, מקווה שכולם שבו מארוחת הצהריים. המושב הקרוב, שלוש ההרצאות הבאות בעצם מתמקדות בהצטברות של המזהמים במארג המזון. ההרצאה הראשונה מתמקדת בחברת הצמחים. מעבדה של פרופסור שמעון רחמילביץ מאוניברסיטת בן גוריון התמקדה בזה בשנים האחרונות, ודוקטור נטלי דה-פלקו תעביר את ההרצאה הקרובה. בבקשה.
Okay, good afternoon. I will switch to English. So the purpose of our monitoring in נחל אשלים for 3 consecutive years, for 19, 20, and 21, was to understand the level of heavy metals that's been uptaken by the plants. The 4 heavy metals that we focus on were chromium, cadmium, strontium, and arsenic. And we also checked fluorine that was in very high level in the water that has been flowed into the river. So we try to estimate the concentration that still has in the plants through checking both the roots and the soil and the leaves. So first of all, I would like to say that the plants, they have a sort of tolerance for not essential materials. So and this ability, it's actually a mechanism for the plants to protect itself. So it does uptake non-essential compounds, but it stores in parts of the plants that it will not use. So sometimes can be old leaves, sometimes it can be roots. But indeed, in a chronic exposure to not essential elements is actually create a sort of a toxicity in plants. So here we are proposing 2 pictures of the sun habitat. And we have on the right a control plot, and on the left we have a sand plot, the polluted plot. So we do see the difference, and we could see the difference in the size of our shrubs on the same species if we went to the control or in the polluted plot. And something else that it's always for us very important to repeat year after year, that in the area we have naturally in the soil heavy metals and metals in general, which actually bring us a very big problem, because we did know since the beginning that it would have been a sort of baseline of concentration of metals in the plants, both in the control and both in the polluted. And this was one of our first challenges. So where is this baseline? Is the baseline the same that what the plant is uptaking? So in the very beginning, it actually confuses for the first year. But then, as being a long-term survey, actually with the years, we could start to understand what is really happening. So our lab, it comes from the agriculture department, so we generally work with crops, and working with crops, it gives us a sort of experience with different type of plants. So we have our machinery and our methods and our protocol actually been used for different kind of plants. So we had to adapt, sometimes with a lot of creativity, our protocol to use on shrub plants. So this adaptation, it started with our work in Evrona, and it moved to Aşlim, and so we could actually, first of all, avoid using some machinery that we cannot use with the shrubs because they have very small leaves, but we could adapt our methods. Some other challenges is that in the sun habitat we had a very poor condition in our plants, and actually a few individuals died. But the individual that died we actually found in the control, in the alluvial, and I'll show you a bit later why, or possible why. And then while sampling the roots, we had a lot of difficulty because the roots on shrub actually go very deep, so we couldn't dig so much without disturbing the plant. And if we tried to take the roots that were more on the surface, we wouldn't actually be very sure if the roots were of the shrub or of annuals. So what we did, we sampling in 2 different habitats. We had the sand habitat and the alluvial habitat, and we chose 3 different species. We had control and polluted plot. So our methods were to determine the heavy metal and the fluorine. So we just collect the samples. We came to our lab, and we use different protocol for the extraction of the elements. And then we use ICP for the heavy metal and IC for the fluorine. So because this year we didn't go out for sampling, and our part of the project it's for something else. We had a control experiment in our greenhouses. Our results are actually the same that we present last year. So we want to just give you an overview and try to present in a different way. So indeed, we sample 3 different species, and we sample different. We had different types of samples. We had the roots, the leaves, and the soil. But what we are proposing here, it's like an axis: soil, roots, and plants. So trying to plotting these sample types together. For actually giving a sort of patterns of what is happening. So here you see on the right side of the screen the sand habitat, on the left side alluvial. You have the ears, so 3 consecutive ears, and this is the concentration of cadmium. So you can see that over time we have an increase in the sand habitat, in the polluted plot, sand, leaves, and roots. I said again, while we have a kind of surprising an increase in our control samples. The contribution of our differences, they comes in the sand, indeed, for the leaves. But when we check the alluvial habitat, we see that the major effect in the control, it comes from the soil. And we actually saw this for other elements. So here we are showing with the same pattern, with the same design, the results of chromium. We do see a slightly increase in the sand polluted plots, but we don't see much differences when we plot all the results together. So the main contribution here again is from the leaves. So the leaves are actually, we have high concentration of the chromium. But when we check the soil, again, in the alluvial habitat, in the control, we have a very, like a higher concentration and an increase over time. The strontium, it has a similar pattern than the chromium, so we don't see, when we plot all the results together, we don't see a significant difference in decrease over time, but we do see in the alluvial and especially in the control. And the contribution here, again, it comes from the soil. So I will go in later on the conclusion of what we think about it, and moving to the fluorine. So fluorine, it's not found naturally in the area. So even though we saw an increase here over time in the sand polluted, we do see that in the leaves we have an increase, but in the soil we don't have a baseline that it's the same. So our time zero, it doesn't represent the same, which means that indeed every concentration of fluorine that has been found in the leaves, it comes from the soil, that comes from the pollution. So how is possible that we have this fluorine? So we have an increase in the leaves. Sorry. So just to offer you a short summary for the different elements divided for the leaves and for the soil. So we do have an increase. This is only for the polluted and for the sand. So we have an increase over time, generally in the leaves and in the soil. But when we check the alluvial parts, as I showed you before, we do have an increase in the soil and mainly in the control. So how is possible? And we, at the beginning, in the very beginning, when we first start to sample, we thought that our results were sort of contaminated, maybe our methods are not working. And only after a few years of sampling that we could see a sort of pattern in our sample, we start to question if our control area in the alluvial part is somehow contaminated. Contaminated not from any events of water, but maybe from some air pollution. And this is really speculative because we don't have any proof of this. But we didn't come out with any other possible explanation. We may thought that maybe the flooding, it's bringing into the river some high concentration of heavy metals. But besides this, we don't have a clear explanation, and if you have any, I'll be very happy to hear. So as I said before, this year we didn't go out to sampling, and we tried to do a control experiment in a greenhouse environment. So why so? Because when we go out and try to sampling plants, sometimes the dynamics are complex. Indeed, we choose 3 different species, and sometimes among the species we have differences because the plants, even though they are in the same habitat, they have different accessibility to water, to nutrients. So we wanted to try to do something more controlled to understand how the pollutants are actually moving from the soil to the plants, and inside the plants we wanted to sample different part of the plant, so old and young leaves and the stem. So we had this experiment setup that we've been using for years for different type of experiments. We work with crops, and we actually ask the same question: where is the element going, where it's flowing? And we have the possibility with this system actually to collect the drainage. So it means that once we input in the system any pollutant or any element that we want to ask, we can actually somehow trace it in a sort of mass balance experiment. So what we did here, we wanted to use rotem to go back to the plants that we had in Aşlim, but we didn't succeed to sprout it. So we used karakash, and maybe it was the very wrong decision that we did, because we started our experiment in October, and karakash, it's not in its vegetative status, so we didn't have much leaves. But still we went on with our experiment. So we used a concentration of cadmium and fluorine that were similar to the one that were in the pool of the factory. And not to the fluorine. Fluorine was, I think, 1,000 more than the ppm that we use. But we try to arrange something that it's not harmful for us to use, even though 150 ppm of fluorine is actually harmful for us. So we had a few pollution events. We actually inoculate the sand with our polluting solution. We finish our experiment. We take samples over time, the experiment. But when we finished, we took out the roots, and we were kind of happy. We thought, okay, the experiment worked. So you can see here on the very left the roots, the root stock of the plants in the control, one of them, and one with the cadmium, one with the fluorine, and on the very right, the one that has the combined treatment. But then when we actually extract cadmium and we extract fluorine from our first and second sampling, we couldn't find, first of all, significant difference between our control. So we thought that we are failing here, and we were really excited to wait for the last sampling, where we actually give much more pollutants, like just to be sure that the pollutant is going there. And our very last sampling, it didn't have no trace at all of cadmium, not in the leaves, not in the roots, not in the soil. And the fluorine concentration, we couldn't determine it now for some logistic problem. So we start to ask if it was the wrong season, if it was the wrong approach, if it was the wrong sampling. So we start now a new experiment where we're working with wheat. We wanted to work with Arabidopsis, but we didn't succeed to let it be in polluted sand for more than 5 days. So 5 days was too short time for us to make an experiment, so we moved to wheat. So what we're doing here, we are seedling the wheat in paper, we move them in a good soil, and then we moved in a sand soil. And we actually have this setup where we have a small funnel where we add sand that is completely polluted. We're not inoculating all the sand is polluted. We transplant our wheat, and then we wait. We are in the very, very last parts of starting the experiment, because once people heard that we're working with heavy metals and we have wheat, we had a lot of people that want to come in our experiment, so the experiment just grow over time. So now we're having also cyanobacteria to see what's the effect of cyanobacteria in the sand, polluted sand, if there is any absorption. So the experiment started to be much more interesting. And about this, I have no results. So I would like to finish here and say that this new approach, by using the funnels, we have the complete sand that it's polluted. We can sample all the plants without any problem, because we have a very small volume of sand, and we have much less amount of waste, because it's something that we have to take always into consideration, that even our experiments are somehow sustainable. So an overall summary about the field experiments. So we do see an increase over time, and we still see an increase over time in the sand habitat, in leaves and in soil. And from our perspective, this long-term monitoring is actually give a way to have a different perspective of results. 1 year, it doesn't help at all to understand what's going on. If we can give any comments for future happening, if it will happen, we would reduce the species. We wouldn't use much more than one species. Maybe we will increase the sample size, and probably one species and 2 different seasons. So the complexity shouldn't be over the species, but in the ecosystem. And regarding the other experiment, not much more to say, just the ratio between the sand and the pollutants should be critical for the successful of the experiment. And thank you very much.
תודה רבה, נטלי. יש לנו כמה דקות לשאלות.
אפשר גם בעברית.
לא. אוקיי.
בסדר.
תודה רבה, נטלי.